Hi, this is Victor and welcome back to my math tutoring channel. In this video, I will show you the trigonometric identities, which are the trigonometric formulas, plus we will do some exercises for concerning those trigonometric functions. The trigonometric identity, I don't have to write them. It's here. You don't need to prove them. All what you have to do is to use them. Let's say the first identity, which is sine square of x plus cosine square of x is equal to 1. So for sure, sine square of x is equal to 1 minus cosine square of x. So I can deduct this from this formula, or cosine square of x is equal 1 minus sine square of x. I think everybody know it. I don't want to repeat it. Those are the formula. You have to take a picture of that, or you can copy them, because we will be using those formula in the exercises that we will do in that video. But anyway, I will refer those formula in the exercise once I use them. Okay? Let's start with the exercises. Exercise number 1, if I have sine of x, cosine of x dx, and I need to do the integral of that. But if I look at my formulas, it looked like this formula here. So the formula, I will copy it here for you. It said sine 2x is equal to sine of x cosine of x. Okay, so sine x cosine of x, I divide by 2 here, I divide by 2 here. I can replace sine x cosine x by sine 2x divided by 2. So this become 1/2 sine 2x dx, and the 1/2 is a constant. I'll take it outside my integral. It become sine 2x dx, but we know the integral of sine 2x is equal to minus cosine 2x divided by 2 plus c. If you want the proof for that, if I want to integrate, I will erase that later on. Cosine 2x divided by 2, the integral of that, integral of the derivative of cosine is minus sine, so it become minus, and then the minus that is here, I have to put it here, minus sine 2x multiplied by the derivative of 2x, which is multiplied by 2, but here I have divided by 2, so this and this would go out, and minus times minus equal to plus. So I will come back to sine 2x. So this is how I came with that formula. I think it should be easy for you, but I repeat it for the beginners of the course. Let's do another exercise, which is a little bit more difficult. The second exercise would be integral of sine 2x, 1 over 1 plus sine x dx. Yeah? I know there is a formula which said cosine square of x plus sine square of x equal to 1. Yeah? So I can so if there is in any way that I can replace that by this, if I can replace it by 1 minus sine square of x, I will have in the denominator cosine square of x. It will go up to the numerator as sec square of x, and there is a formula for integral sec square of x. So let's see how I can replace this denominator by that. So if I take 1 over 1 plus sine of x, I can multiply by 1 dx. Yeah? But my 1, I want to write it in more intelligent way. Instead of writing 1, I'm going to write multiplied by 1 minus sine of x divided by 1 minus sine of x, which is equal to 1 dx. And here, I see 1 plus sine of x and 1 minus sine of x, and I know the formula a square minus b square is equal a minus b times a plus b. I will put the plus here. It's the same thing. A plus b times a minus b. I put the plus here because I started with a plus here. That's why. But you can put a minus b times a plus b, and it will be the same thing. So now I can replace, and in that case, this is my a and this is my b. And so a plus b times a minus b. So I can replace the 1 by 1 square minus the b, which is sine x, by sine x squared. But in the numerator, I would have 1 minus sine x dx. I will erase the formula here. Just wanted to show it to you. So now it will become integral of 1 times 1 minus sine x is 1 minus sine x divided by 1 square is 1 minus sine square of x dx. So because there is a minus here, I can split it into two integral of 1 over 1 minus sine square of x, and I will take the minus outside my integral, sine x divided by 1 minus sine square of x. Yeah? And both of them, there is a dx here. We always have to add the dx. So I take the first integral here. 1 minus sine square of x is equal to cosine square of x from the formula that we showed it here. So if the sine x comes here, it becomes 1 minus sine square of x, it will equal to cosine square of x. So the first integral will become dx over cosine square of x minus, and 1 minus square of x, again it's cosine square of x, so it became sine x divided by cosine square of x. But instead of writing cosine square of x, I want to write cosine of x times cosine of x dx. So the first integral, 1 divided by cosine square of x, is equal to sec square of x minus, and here this is tan of x times, because it's 1 divided by cos, it's equal to sec of x dx. And here there is a dx. And now there is a formula, the integral of sec square of x is equal tangent of x. It's equal tan of x, the first one here. I will put plus here at the end, minus the integral of tan x sec x is equal to sec x. It's a formula too. Sec x plus c, and that's your final answer. Let's do another example, and I will end this video with this example, and then I will do another video with a lot more examples. So let's take the integral of between 0 and pi over 4 of square root 1 minus cosine x dx. So what's bothering me here is the square root. If I can get rid of the square root, then it will make my life easier. To get rid of the square root, if I can make this the entire under the square root as to the power of 2, then I can get rid of that square root. And now I know there is a formula which I saw at the beginning of this video, which is sine square of x equal 1/2 1 minus cosine 2x. And I look at that formula. Here I have 2x and here I have x. So let's make that x as 2x. So 0 and pi over 4 square root of 1 minus cosine 2x divided by 2 dx. Yeah? So now I take that as my x, and then cosine 2x. I would have cosine 2x. So it's a time here. That's the formula. So if I have 1 minus cosine 2 of x, if I do cross multiplication, I will have 2 sine square of x. So 2 sine square of x is equal to 1 minus cosine 2 of x. So I can replace this. This is an x here. I can replace this by 2 sine square of x. But here in my case, x is equal to x divided by 2. So my integral becomes from 0 to pi over 4 square root of 2 sine square of x over 2. And now I can get rid of the square root. So this will become integral 0 and pi over 4. I can take the square root of 2 outside my integral because it's a constant, and square root of x squared of x divided by 2 is sine x divided by 2 dx. So now it is easy. I know the integral of sine is minus cosine multiplied by the derivative of the axis. So I will keep square root of 2 and it become minus cosine x over 2 multiplied by the derivative of x over 2. Divided by the derivative, divided by 1/2. And this will be between 0 and pi over 4. Now let's take this outside my parentheses. I have square root of 2 divided by 1 over 2. It becomes 2 square root of 2 of, I will take the minus outside my parentheses, cosine of x divided by 2 between 0 and pi over 4. And at the first I replace x by x divided by 4. So I would have, forgot to put minus 2 square root of 2, minus 2 square root of 2 cosine x, cosine pi divided by 8 minus, let me write them down. It's cleaner. So it becomes minus 2 square root of 2, and I open my big parentheses. It's cosine pi over 8 minus cosine 0 over 2, which is cosine 0. And if you do that, cosine 0 is equal to 1. So it becomes minus 2 square root of 2 cosine pi over 8 minus 2 square root of 2, because minus 2 square root of 2 times 1 is square root of 2 over 2. And if you do that on your calculator, you will have almost equal to 0.22. If you do cosine pi over 8 and then multiply it by minus 2 square root of 2 and you subtract it from 2 square root of 2, you will have 0.22. I will end my video here, and I will do another video with more example about the trigonometric formula, integral of trigonometric functions. So if you like my video, please subscribe to my channel. That will help me, and it will encourage me to do more videos for you. Thank you.